We are looking at problem 1023, risk and capital budgeting. So we're going to be looking at an existing portfolio and analyzing the additional risk of adding to the existing portfolio. So I'll let you read the details of the scenario, but for our purposes here, we want to look at, first we want to calculate the mean or the expected value or the internal rate of return of this project. And instead of having cash flows here, we have a group of 5 possible internal rate of return values and the probabilities of each one happening. So we're going to figure out the mean or the expected value most likely to happen from this data right here. So we just simply want to put in our possible IRR values, 2, 5, 9, 13, 16 right here. So 2, 5, 9, 13, 16. And then over here we want to put our probabilities, which is 0.125, 0.2, 0.35, 0.2, 0.125. So 0.125, 0.2, 0.35, 0.2, and 0.125. And that's going to give us our mean or the expected internal rate of return for the new park, Glinda's Gulch, 9% with a standard deviation of 4.32%. Now we want to look at the expected internal rate of return for her existing portfolio and the standard deviation, which if you read up here in part C right here, the IRR is 8% and the standard deviation is 2, and then we're going to calculate the coefficient of variation for Dorothy's existing portfolio. So 8% here, 2% here, and we have a coefficient of variation of 0.25. Now, if you remember, the lower this is, the lower that this EV is, the lower the perceived risk. Because if you have a low standard deviation in the denominator versus a higher mean in the or higher expected value in the I just said that backwards. This is the numerator. The standard deviation is in the numerator. You want that to be high, or low, I should say, low, because you want this to be low. I'm talking in opposites here. You want the numerator standard deviation to be low, and you want the expected value in the denominator to be high, and that's going to give you a low coefficient of variation, which is a low risk. Okay. Let's keep going here. So now we're looking at part D right here, where we're going to calculate the expected internal rate of return if of Dorothy's portfolio if the Glinda's Gulch project is adopted. For this calculation, assume that Dorothy's new portfolio will consist of 80% of existing parks and 20% of the new Glinda's Gulch park. So right here we want to put those percentages in. So here we want to put 80% and 20% here. Excuse me, and that's going to give us the expected internal rate of return for the combined portfolio. All right, now we have a correlation that's perfect. So our R value is going to be 1. So the correlation. So these parks, because they're similar, whatever happens to one is going to happen to the other one. If it rains, or if we have some kind of a national disaster that keeps people from going to the parks, or if the economy is doing very well, which means people can take more time off and visit the parks, that's going to affect, we're assuming, that's going to affect all the parks equally. So we have an R value of 1. We're going to put that right here. and that's going to factor into this this equation right here. You see R right there, and that's going to give us our standard deviation of the combined portfolio, because I've got this long formula right here in Excel form right up here. You can see it. It's going to give us a standard deviation, and then a coefficient of variation of the combined portfolio of 0.3005, and then this box right here, it's already done for us. This gives us the difference between the two coefficients of variations is positive, which means so it's asking here. We've already done part F, calculate the coefficient of variation of Dorothy's new portfolio. We did that. Right here. Let's see, where is that? Expected our existing portfolio. Expected portfolio, CV of combined portfolio. C48. I'm just trying to make sure I get, okay, combined. Okay, let's go back up here. Oh, I see. I just misread it. So we're calculating the combined here. It says a new portfolio. It doesn't say combined. It's kind of the wording's just tricky. I'm trying to go too quickly. So this is the combined, which we have right down here, right here. Now what we're doing, sorry, is we're comparing. So we're comparing the coefficient of variation of the existing portfolio, which is right here, 0.25, right here, with the combined, and we're looking at, and we're just comparing it, and we're going to see that the CV or a coefficient of variation is slightly higher, which means that by adding this project, we're going to slightly increase our risk. Slightly, not a whole lot, but a little bit. So make sure that you answer all these questions here well, you've got the answers here. You just need to write them in or type them in down here, and that will complete problem 1023.